Okay, great. Okay. Well, thanks everybody for joining. Today we have a lunch and learn from Rudy Alexander from Breadware, and he's going to talk to us about industrialized IoT solutions. Um, so he's got, I don't know, a dozen or so slides. What I'd like to do is for this lunch and learn, if you have any questions, put them in the chat and I'll collect up all the questions. Then at the end of the presentation, I'll read them back out, and that way the questions will get captured as part of the recording. So if you don't mind, send me the questions or send them in the chat and we'll go through them at the end, okay? But otherwise, Rudy, I'll hand it over to you.
Okay, thank you so much. I appreciate it, and thank you all for joining us today. And good afternoon or morning or wherever you are. So today, what I'm going to do is just really spend some time talking about the predictability and industrialized solutions for the IoT world. Some call it the Internet of Products, some call it the Internet of Things. But I'm going to talk to you a little bit about what's happening in the market and why it's important, and some of the benefits of it. And I think for me, it's always good to go into a couple case studies that are actual real world scenarios that look at the impact this has on the problems we're solving. So again, thank you guys for being here, and we'll jump right in. So, IoT really is transforming the industrial facilities and the plants. I was just presenting at a big conference back in early, I guess it was October, and it was very well attended for the American fuel and petroleum and manufacturers industry. And it's obviously everybody's talking about digital transformation and everything around that. And basically, the Internet of Things can provide a comprehensive view of the factory floor, amongst other things. It's in the environment through a network of connected devices, sensors, and software. So, well, and the way I always kind of categorize this is that the technology, the Internet of Products, Internet of Things, the technology is a delivery vehicle. What's most important is the problems and the challenges that the technology is solving and the benefits from that. So things like asset tracking, predictive maintenance, and analytics on the particular machine failures. And of course, it's just one thing to be able to do predictive maintenance on those machines, but you also want to be able to identify what the problem areas are, and so you can do some troubleshooting and put that in the hands of the engineers or the folks that are fixing the machines themselves. So it'll extend the lifespan of a lot of equipment, enhances the workspace by identifying potential hazards. Like, for example, one of the key examples of this is in the area, for example, gas leaks or leaks that could be hazardous to the factory floor. Obviously, hazardous to the entire plant, or anything along the lines of any type of vapor or any type of gas that's leaking that you want to be able to monitor is just one example of many things that can be done. And of course, everybody is talking about AI and machine learning, right? And so what's really important around AI and machine learning, there's multiple applications around it. But the big thing to learn about this is, first, you have to capture the data. You got to structure the data. You got to develop some analytics around that data. Then your machine learning obviously begins to occur. And then algorithms are put in place to really do artificial intelligence and what that means, so that you can get some real predictability into failure and do some different things, like even create real world virtual scenarios for clients who are doing maintenance work out in the field or things of that nature. So it really is transforming the industry, and tremendous growth worldwide across the industry in the area of industrial manufacturing and IoT in general. So we're excited about what's going on today and excited about what the future holds. Some of the challenges that's being faced out there and some of the things we're working on is, obviously, there's labor shortages out in there, and skilled labor, and just like me, maybe some of the labor is aging out. So, but we're addressing some of these things because it's easy now. We're collecting data, and there's a lot of data out there. And when we collect that data, we're able to analyze it and, again, place some of the artificial intelligence on it, which means that the companies out there that we're dealing with need less skilled labor and or less labor associated with jobs that are highly skilled. So obviously, resource management is a big part of what we're addressing. Quality controls. We talked a little bit about safety. Some aging infrastructure out there. There's tons of aging infrastructure. You want to be able to determine where you want to fix things and what you want to fix first, so that you can monitor aging infrastructure, so that you have a development plan to be able to replace that infrastructure, fix it, or whatever the case may be. Of course, we're all dealing with some economic uncertainty into the world, worldwide. And so we're all being asked to do do more with less, excuse me. And so we're addressing that as well in this type of technology. This is all about the digital transformation that's taking place in the world. And these are just some of the challenges that we all face, depending on your vertical or your industry. It could be different, but these are some that are pretty common across every vertical itself. So what are we trying to do? And we're leveraging these smart IoT solutions in the facilities and in different applications, et cetera. First of all, we're trying to get to data-driven decisions. What does that mean? Well, data-driven decisions means that we've collected data, again, we've structured data, and we are able to present data in a organized format through a dashboard that is what we call actionable. So if you can put the right data in the hands of the engineers, and you can provide a dashboard where they can just work with the parameters of what they're looking for, then you can give them actionable items to go fix a problem, change a problem, design a problem, whatever the case may be. So in the area of predictive maintenance, to being able to have some predictive maintenance on being able to get ahead of a problem or a failure rate related to machines. I'm going to go through a little bit of that in the case study, a couple of them when we talk. Asset tracking. This one is a fairly simple application, but it's also a really important one. I will tell you, for example, got a lot of experience in the utility industry, and I'm sure this will make you all feel really good about our grid. But the majority of the utility companies out there don't have any idea where all their transformers are. And so this is a great way of tracking those, but not only tracking those assets, but also putting predictive maintenance programs in place so that they're not going out and putting people out of power because of rust or damage or just aging out, et cetera. And they can get to them much quicker is a good example of that. We talked again about improved safety. There's multiple applications associated with that. Of course, we talked about the gas example and identifying and analyzing potential failures. It's one thing to be able to do predictive maintenance, but you really want to be able to not only identify the problem, but be able to troubleshoot on what you need to do to fix that problem. And in most of those cases, you want to be able to put the data in the hands of the engineers and those manufacturing engineers or EEs or whatever the case may be that are fixing the actual equipment for you. So greater efficiencies, throughput, faster, obviously that's a key point of this. So these are just some of the examples. There's many, many more where we're leveraging the smart IoT solutions and deploying the sensors and obviously the software that backs that up. So how can companies help you, and what's some of the key points to look for and keys to success? End-to-end development. You want a reliable partner out there, from product definition to solutions architecture to the software, et cetera, and all the certifications you may have to go through for the devices themselves, or depending on the vertical in the industry. An end-to-end solution partner is really critical. That means you want somebody that can either do off-the-shelf devices, which are available. We as a company obviously provide those. You want to be able to do customized work where it needs to be done, and we do that as well. And you want to be able to provide a software platform that can do all the analytics and all the performance around the data and the AI and machine learning. So you want a full end-to-end solution as it relates to what you're looking for in the marketplace. Data integrity and security, obviously data integrity and everything around that. You want to be able to deploy a sensor network that's providing sufficient data, right insights. What is it you're looking for? What is it you're trying to identify? What does that data look like? How do you structure it? And then obviously around security, security is always an issue and always needs to be addressed, whether that's in a cloud or an on-premise type solution. You want to make sure that all the security implications are in place. Obviously, you don't want a lot of this data being exposed to the general market. So, and then this is so underrated and always said and everything, but not many companies address it. It's the quality of your user experience. If you've got to spend 6 to 9 months to a year implementing a system, it's the wrong system. There has to be a quality user experience associated with the data, what you're analyzing, where your predictability is into that, and that it's secure. Key points in when you're deploying any type of IoT solution and what you're going to market with. So let me take us through a couple of case studies, which I think are interesting ones. This was actually an industrial pump manufacturer. This pump manufacturer is a worldwide company. Their key industries are oil and gas, food and beverage, military. There's literally millions of these pumps out into the marketplace worldwide. The pumps that they have out into the space, they obviously, because they're turning a lot of different fluid mixtures, et cetera, they're going to have some failures. And so they've experienced some cavitation, dry runs, periodically reducing the life of the pump. And they're unable to monitor the pumps close enough to track these conditions. So again, the ability to be able to put sensors on those pumps and be able to track those pumps, the performance of the pumps, develop predictability maintenance around them, troubleshoot where one's going to fall is really critical. Why is that so important? Because at the end of the day, depending on the application of the pumps and these millions of pumps that are out there, it could literally cost the client, the customer, anywhere from $125,000 a day to millions a day, depending on the application. So always get the question, well, why wouldn't they just have a second pump? They can just very quickly implement it. Well, it'd be really nice if you could very quickly implement it. The problem with that is that you just have to retool yourself. So you've got deferred work. You've got to get people in the unplanned shutdowns. You've got rescheduling critical skilled resources. So there's a rescheduling issue. There's just unplanned switch time. There's just a multiple of things that you have to address, which continues to obviously disrupt the workplace and obviously disrupts the efficiency and also makes it much less productive. So it's very costly to the organizations. And what this actual pump manufacturer wants to do is maintain their leadership in the industry. They are the top pump manufacturer in the world, and they want to be able to maintain that. And they have identified through years of research that in order for them to maintain their position, they will need to stay leaders through digital transformation. And digital transformation is in the IoT world, or right in the wheelhouse of what we do as an organization. Digital transformation also takes place from a cultural perspective, but that's a whole nother set of slides and a whole set of other information. So maybe one day we'll get to touch base on that. But certainly from a technology perspective, IoT plays a major role in the digital transformation of companies around the world. So that's why this pump manufacturer wants to stay ahead of their competition and wants to be able to fix some of these challenges. So this is actually what we did for them in this case study. Is we actually developed a sensor because we had evaluated the sensors that were out in the marketplace that were off the shelf. We have our own sensors that are off the shelf. Our sensors address somewhere in the neighborhood of probably 60% of our clients that we deal with off the shelf. So that means that another 40% of them are either bought off the shelf somewhere else, or roughly somewhere in the neighborhood of 25% is done customized work. In this particular case, it was all customized. So we have a staff of EEs and firmware engineers, software engineers, et cetera, where we do a customized sensor because of what they were trying to accomplish. And they placed these sensors actually on the pumps themselves to monitor the vibration of the pumps and the decavitations of the pumps, and to be able to provide that data back into to be able to collect that data and then be able to provide that data back in through a gateway wirelessly into our RISE platform, software platform, which is a proprietary software platform does. So what happens there is they're monitoring the pumps. They know exactly from a vibration perspective what's taking place. They know exactly if there's any level of decavitation or any type of issues related to the performance of the pump. They are then delivering that data consistently back through the wireless network into the RISE platform. The engineer is then able to look at the data, analyze that data. Some intelligence and structural data analytics is applied to that data. And then he or she, from an engineer's perspective, can determine if there's a problem area or if they're going to have an issue related to pump failure and the timing of that. Big deal. And it's a big deal because if they can get ahead of that problem, back to the previous slide, it means that they now are able to have consistent runtime of their pumps without being down, and it saves them hundreds to millions of dollars. And so a lot of things come into play there, but it's a great example of an application that has tremendous impact on a digital transformation in a company like this industrial pump manufacturer that we're dealing with. So back to the kind of the software solution. So it's one thing in these solutions of IoT and what's happening in the marketplace related to digital transformation. As I'm sure all of you know on this call, there's no shortage of data. There's no shortage of data from our customers. There's no shortage of data that's out there into the marketplace. And now we're collecting more data, right? So we've got our existing data, we're collecting more data, we're collecting different types of data, et cetera. And so it's one thing to have a sensor that collects the data or be able to integrate your current data into an existing system like our RISE platform. But you've got to be able to structure it. You've got to have the intelligence around that software to be able to analyze that data. You've got to apply some machine learning and AI around it to really get the value that you're looking for. So, and here's the key to this is, we've all heard garbage in, garbage out, right? So if that data is not properly addressed, if you don't have a software platform that's doing the analytics around that, if you don't have proper parameters and structure around that data to be able to evaluate what you're looking for, and most importantly, if you don't have a very simple interface or dashboard that an engineer could look at it and really start to make some sense out of it without having to be trained on as a CPA or a Six Sigma expert, is really important because these things happen real time in some cases. These things happen very quickly. In some cases with these pumps, for example, they'll have some predictability into a pump that's maybe going to go out in 2 weeks' time, 30 days' time. So they've got to deploy the correct resources to go out and fix that or replace that pump immediately so they do not have any downtime associated with it. Right. The software solutions, the IoT software solutions that you got to look for is they can be rolled out across the corporate portfolio. That means that there has to be integration back to some of the data. It has to be integration associated with some of the current infrastructure that companies have in place. And once you've done all this, it requires less support, it's seamless. And most importantly, you're putting the tools in the engineer's hands that they can do what they do best, which is engineer. And whether that's, again, manufacturing engineers, double E's, pick your favorite engineer, and be able to solve these types of problems. Okay. So this is actually, excuse me, let me go through here. This is actually a second case study I wanted to share with you. It's an industrial manufacturer of water systems. I think this is a bit of a slide misfunction here, so I apologize. I'll explain more in detail about it. But this industrial pump manufacturer that we're talking about here is a actual machine shop equipment. And what this is, for example, on the factory floor, in a lot of corporations, you have CNC machines, you have lathe machines, you have milling machines, a host of other different things. You also have, in the case of the industrial pump manufacturers, hardware solutions and software solutions. And you have some standardization out there, which is Modbus, fluid level controls, standard temperature sensors, CAN bus, et cetera. And so what we did with this actual client is we actually developed a sensor, and this was used off the shelf for monitoring and utilization around high pressure water systems, and being able to monitor that and look at failure rates, being able to fully integrate into some of their CNC machines at the factory floor, related to their AC unit, electronic control unit, and obviously, again, utilizing the RISE platform and everything around it. I want to key on a little bit around some of the Wi-Fi stuff associated with this, and I'll tell you why is because when it comes to wireless communication and WANs and et cetera into the marketplace, now you really want to look at companies that can support multiple WANs, such as Wi-Sun and things of that nature. And then depending on your application, you'll need to look at how large are those packets of data that you're communicating back and forth with. What does that look like? Can the Wi-Fi network and the wireless network support that? It's critical to the application and critical to the implementation. So in this case, we did use the industrialized controller that we use off the shelf. It's completely off the shelf, no custom design work, which is, with the exception, there is some firmware work with it that's relatively small, but each application will have its own firmware application or firmware development software application with it. So again, it's very similar to the other application. The only difference is this was an off-the-shelf, and it utilized a high wireless network, high data packet, being able to send large data packets across the network in remote areas and things of that nature. So really was a neat project. Saw significance associated with it, significant responses to it. Again, the software solution was all about the actionable alerts that can reduce machine wear and increase operator safety. Advanced analytics tools, optimize machine operation, the unified maintenance plan across all locations. These are things that are extremely important to understand, and when you look at it and have a holistic view on digital transformation and what IoT can do for you across these different applications and across your enterprise. So there's multiple applications associated with IoT. There's multiple solutions. There's multiple problems that are being solved, but it has to be one integrated solution that's solving an array of these types of challenges, or the majority of those challenges. Okay. So that was kind of really it for me on the presentation itself. I wanted to keep it short and sweet, and obviously chat you through some of the fun, exciting things and some of the implications that are happening around digital transformation and everything around the IoT world. I go back to this initial slide, which was the second slide of the show, only just to kind of come back to what are the problems we're solving. And so I always say that technology is a delivery vehicle to solve the actual real world problems. Southern accent coming in with some of the challenges associated with IoT or other applications. So, we had predictability, it's improved efficiency, reduced downtime, all are big buzzwords I'm sure you guys have all heard, but and we're solving these problems, but you got to have a solid technology from a foundation standpoint to be able to deliver the results associated with it. Again, asset tracking, predictive maintenance, extend the lifespan of your equipment, enhance workplace, AI, machine learning. These are all challenges that are being solved through the implementation of IoT that are providing real financial impact to companies around the world. And so we're excited to be a part of it. We're excited to see what's happening and what the transformation is happening in the industry. And with that, I'll stop talking and maybe take a few questions.
All right. Thanks a lot, Rudy. And I would ask folks if you could put your questions into the chat. I'll read them out and we'll kind of go through them that way. Okay, so here's a first one. How does your customizable IoT portal enhance the user experience? And what types of data visualization capabilities does it offer for clients?
Yeah, good question. So how does
This is
it
from
enhance?
Kiana, Washington. Yeah.
Okay. How does it enhance the user? The way that it enhances the user is the fact that, again, I think I mentioned earlier that there's plenty of data out there. And so just producing raw data to a user isn't very useful. So what you want to be able to do is produce data that's been structured in a way that it's structured around solving that problem in a dashboard format. So very simple dashboard that in some cases customizable within our software, and sometimes it's generic, depends on the challenge. But it's a customized or generic dashboard that presents the data to the engineer, and then the engineer or the user can put proper parameters around that with their knowledge, and they can produce the data, which makes it actionable. So then they can take action on what they need to do, whether that's predictive, whether that's fixing something, whether that's troubleshooting, whatever the case may be. All right. And as far as the visualization side of it, we offer multiple visualization type tools, some of which is proprietary, some of which just is integrated into our software to be able to visualize exactly what's happening with the problem too. So if it's a actual pump, or if it's a sensor or that's gone down or whatever, if it's monitoring water level, temperatures, etc., we can actually visualize what's taking place with the actual problem, and that makes it. I know for me, I'm a visual learner. Most people are. So if I can get the data tied to the visualization of it, I can make decisions.
Thanks, Rudy. So there's a few more questions in the queue. This one is from Martez W. And the question is, how do real-world industrial controllers compare with something like the ESP32 line of controllers? So this is something new to microcontrollers as a topic here. So just kind of general question.
Say the question again. I'm sorry.
Yeah, sorry. So how do real-world industrial controllers compare with something like the ESP32 line of controllers?
I can't give you a good answer on that. I don't know specifically, but we'll get you the answer to that. I'm not familiar with that one. I know that some of my engineers probably would be, but
no worries. Okay.
I don't know.
Okay, no worries. The next question is from Scott Gerard, and it says, it's around data storage. So it sounds like you ship all your data to the cloud or central server. Do you also process data at the edge? AI at the edge, of course, can significantly reduce bandwidth.
Yes, absolutely we do. And edge computing is very critical to what we're doing, obviously, when you're dealing with those large volumes of data. So yes, we do that. It's really important. We've got a number of AI initiatives underway as we speak as part of our product development roadmap and some of the things we're doing, and it obviously includes edge computing. Yes.
I have a question for you, Rudy. So this didn't come in, this is for me, but how do you, when you're partitioning the system, how do you make that decision? Because when you do the edge, computing at the edge, I see the benefits, but it's also some cost and complexity at the edge as well. So what kind of considerations do you put into partitioning your system when deciding whether you're going to do it, how much to do at the edge, how much to do back in the core?
Yeah, it's all dependent, to your point, around the application itself, because and the volumes of data and what's taking place. And of course, I've got some very talented software engineers as well as double E's, et cetera, that make those decisions and are a lot smarter than Rudy. But obviously it depends on the application itself.
Okay, that's fair. Thanks. Next question is from Sid Gupta, and the question is, do you have any open source set of offerings that would enable developers or firmware engineers to sort of try before they buy?
The answer is we do not. We obviously have try before you buy licenses that we can, that people can use and people can work on stuff, et cetera. But we no open source. There's a lot of companies out there that do provide the open source side of things. What we do is we allow our clients to white label what we're doing, and then we allow them to take that, and they can write to APIs and they can write information to it, et cetera. But it also allows them to be a part of our product development roadmap. What we found is just two different business models, right? And so for us, we can provide a much more robust solution with integration and APIs and being able to offer the white labeling capability versus doing open source development code.
Okay. That's fair. I think I know the answer, but I'll kind of follow up with. There was a follow-on question to that, and it was, this was from, I think it's Scott Gerard. Sorry, yeah, Scott Gerard. Are your edge platforms your own platform? I think you said they are, or do you use some kind of open source platform like EdgeX? But I think it's your corporate.
That's correct.
Yeah. Okay. Does your product meet this? Sorry, this question is from Barbara Cosgriff, and her question is, does your product meet the NIST SP 800-218 secure software development framework? So I guess a question around data security and protection.
Yeah, it does. And just for clarity around that, we also we run on GCP. So as in anything that's around the GCP security levels, et cetera, we obviously are part of that and get the benefits of that associated with it. So that now there are times, especially when you're dealing with regulatory industries like the utilities industry and stuff like that, where they require additional security, like there's a SIP, critical infrastructure protocol, and we will do that depending on the application. So it just depends on the level of security, but we have implemented all the kind of standard generic type of security in the system. So that's a big, very good question, because a lot of companies have not.
Yeah. Cool. Let's see, folks. That's the end of the list of the questions that I see. So if anybody has any remaining questions, throw it out here and we'll get it answered. Otherwise, Rudy, I mean, I think it's really interesting. Thank you so much so for the folks out here who don't know, Rudy got called into this presentation about a half hour before the end. Before we presented, there was another person was going to speak and something came up. So he stepped up and got it done. So it was really interesting today. So thank you so much for that, Rudy.
Yeah, absolutely. And thank you guys all for your time today. I really appreciate it. And if there's any follow-up questions, just let us know. And, good luck to everyone in your digital transformation. There's a lot of exciting things happening out in the market today. And even with this crazy economy we're living in, there's still really a lot of great things happening and a lot of things getting funded. So it's a good time.
Thank you so much. And for the folks out who have been sort of throwing the comments out there, I'll let Jen know that you missed her. I'm Greg Dunko. I'm the director of strategy here at Riot, and Jen is traveling, so she asked me to step in. So lots of substitutes on the call today. But anyway, thank you all so much for joining. I hope you found it beneficial. I found it super interesting. So long, all.
Thank you all. I appreciate it. Bye-bye.
Yeah. Bye now.